Hello. Today we're going to talk about how to do a shortcut on graphing lines. We've been able to get points in lines, and we've found out how once we have the points to get the slope. We're going to show you a cool little shortcut here. First thing we're going to do is take these lines right here, find 2 points in them, and then find the slope from those lines. So here we go. We're going to do this little cute XY plot thing here. Say, okay, what's the nicest, easiest one to do? 0. You like stick in 0 there, and you get y equals, that guy goes away, and then have 5. 0, 5. That's a nice point, nice easy point. I'm going to pick another nice easy one, something that I can stick in there that'll get rid of that 3. If I stick 3 there, I get y equals 2/3 times 3 plus 5. Look at that, 2/3 times 3 is 2. So I get 7. So 3, 7. Now we're going to find the slope. Remember, slope, we're going to take y2 minus y1 over x2 minus x1. And we get 7 minus 5 is 2. 3 minus 0 is 3. Good. So we just found the slope. So if we were to graph this, we would have, here we have 0, 5 is up here about right there. And then we have 3, 7 is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 would be about right there. Good, good, good. And we can see that between this point and this point is the slope. And if you look right here, you can actually see the 2 and the 3, that it went from the level 5 to the level 7. And then it went from 0 over to 3. So it went up 2 and then over 3 to that next point. Good deal. Let's do the next one here. Little XY plot here. So again, 0's, it's just too tempting to get that intercept. So here we have 5 halves. Gives you 5 halves times 0 minus 3. That 0 cancels it out, and you get a negative 3. And then a nice good one, I'm going to stick a 2 in there, so we get y equals 5 halves times 2 minus 3. And that's gone. 5 minus 3 is 2. So we have the point 2, 2. Now to find the slope, we're going to go y minus y. Let's do negative 3 minus 2 over 0 minus 2. So we took y1 minus y2 this time. 0 minus 2, and that gives us a negative 5 over a negative 2. That simplifies down to 5 halves. Good deal. So if we graph this, we have 0, negative 3. It's about right there. And then the next point, a 2, 2. 1, 2, 1, 2. And there's the line. And you can see, again, that slope, 5 halves, is illustrated 1, 2, 3, 4, 5. 1, 2. So it's up 5 over 2. And there we have it. There's the line. Good. And one more. Here we're going to have the xy. Stick in a 0, and we get 1. That's so nice. Notice that these, well, and for the next point, let's stick in something like, I don't know, 22. That'll get rid of an 11. Y equals negative 7/11 times 22 plus 1. That's y equals, times that through, and we get a negative 14 plus 1. Y equals a negative 13. Good. Slope here. If we do the slope of this one, we take y minus y over x minus x. So that's going to be 14 over 22, and that will reduce down to, negative, sorry about that, negative right there. 7 over negative 11, so negative 7/11. Good deal. And if we graph this, we have the point 0, 1 is about right there. And we're going to go over 22 and down at negative 13, about right there. And here we have this line going down like that. Great. Now, looking at where the slope is here, the slope went down for these 2 points. It went down 14 and then over 22. Or reducing it, it goes down. Oh, we could have had a point right in there if we would have gone down 7 and over 11. That 14 over 22 reduced down to 7/11, but you get the same exact thing here, and you can see this point. I don't know. Let's find out what that point would be. If we went down 7 from y being 1, that would put us at a -6. And over 11, so from 0 goes over to 11, so that's 11 -6 is that point right there. 11, and you can try this. Stick in 11 in for that x, and you get y equals -7/11 times 11 plus 1, and we get -7 plus 1 is -6. Oh my word, look at that. Isn't that fascinating that the slope could help us get a point? Now comes the really cool part of this. This is all stuff we've done in the past, but you'll notice we went all the way down here. We found 2 points. Then we found the slope. And we ended up with this number. And some of you may have noticed this before. Look at that. There's the number right there. We went down through here. We found 2 points. Then we found the slope. And we ended up right there. Oh my goodness, look at that number. We went through and even picked up some weird numbers, and look at this. The slope is right there, which is fascinating. We could actually, instead of doing all of this, watch and see what we could do. I'm going to graph all of these exactly the same way, but, well, we're going to get exactly the same line, but we're going to do it a lot quicker now. Watch this. So we're going to write up here what that shortcut is. When y is by itself, the number in front of x is the slope. And then this guy right over here is the intercept. So we still have 1 point that's really easy. So let's do this line now. We're going to go and graph it. First of all, you can tell me right away the slope, y is by itself, there's the slope. Slope is 2/3. And we have a good point, 0. We'll knock out that, 5. So we get 0, 5 is right there. And then the slope is 2/3, and that tells us where the next point is. We can go up 2 and then over 3. Right there, there's the next point. And if you want to figure out what that point is, you can. You can add 2 here and add 3 there, and you get the next point. But you see how fast that went? So next one, the slope is going to be 5/2, and the intercept is going to be 0, -3. So we go 0, -3, and we go 1, 2, 3, 4, 5, 1, 2. Go up 5, over 2, whoosh, and we graph the line. The next one, slope is going to be -7/11. That was nice. And the point 0, 1. And we don't have to go through the whole process to find the slope. We can just pull it right out of there. 0, 1 is right there. And go down 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's the next point right there. And we have that line, down 7, over 11. Notice we could have had the same line if we would have gone up 7, +7, and backward 11. And this, when we have it with y is by itself, put a little variable over there to represent the intercept, this is called slope-intercept form of a line. Y equals mx plus b. It's so nice because the slope, when y is by itself, is right in front of x, and then b is right there.
Let's quickly review how we graph lines using these other 2 ways. We first learned about the pick and stick method. Basically, that said, hey, pick 2 values for x, and it doesn't matter which 2 you pick. You can pick 5,000 for your x value if you really want, or 70 or whatever. Usually you should pick kind of easy numbers. I'm going to go ahead and pick 1 and the number 4. Once you pick those 2 x values, you stick it in. Pick and stick. So we plug 1 in. I get -2 times 1 plus 3. -2 times 1 is -2 plus 3. That comes out to be just 1. So I'm going to graph the point 1, 1. Remember, this represents a point, the point 1, 1. So 1, 1 is right there. Now I'm going to stick in another number. I picked 4. So when we pick in 4, I'm going to do stick in 4. Negative 2 times 4 is negative 8 plus 3 comes out to be negative 5. So the point negative 4, 4, negative 5 is what I need to pick. Graph 4 and negative 5 is right here. And so my line would look like that. The second way we discussed about graphing was using the x and y intercept method, in which you just find the x-intercept and the y-intercept and then graph them. So to find the x-intercept, you simply let y equal 0. And to find the x-intercept, you simply let x equal 0. So if we did the same line, y equals negative 2x plus 3, and first of all we let y equal 0, so we'd put 0 in here for y, and we need to solve for x, so I'd subtract 3, and then divide by negative 2, so I get x equals 3 halves, which is 1.5. So I'd graph that. This is the x-intercept, and it's at 1.5, comma 0. Whoop. And then to find the y-intercept, we let x equal 0. If I let x equal 0, I get y equals negative 2 times 0 plus 3. Negative 2 times 0 is just 0, so I get y equals 3. And again, we get the same line graphed. We just used a slightly different method using the y-intercept and the x-intercept. So this brings us to our last method that we're going to be talking about today, which is using the y equals mx plus b format of an equation. So again, we know that m represents slope and b represents y-intercept. We talked about that a lot in our last lesson in 3.4. So if we know the slope and the y-intercept, we can actually graph a line as well. So let's say I've got the line y equals negative 3x plus 5. So I know what the y-intercept is. The y-intercept is 0, 5. And the slope is negative 3. Remember, slope is always with the x. So to graph, you simply would first graph the y-intercept, and then second, use the slope to find another point. Use slope to find a point. Let's show you how this would work. I'm going to graph the point 0, 5. 0, 5 is right here. Now I know the slope is negative 3. So remember, slope means rise over run. And so we could write negative 3 as negative 3 over 1. That means we would rise negative 3. I'm going to go down 3 from the y-intercept. 1, 2, 3, and over 1. And that right there would be my point. And then once you have 2 points, so again, we use the slope to find the second point. Once you have 2 points, just connect the lines. Okay, let's do a problem with a fraction in it, just so you can see how this works, the same idea. Again, you're always going to want to find your slope and y-intercept. Here's the y-intercept. Y-intercept is 0, 4. Always graph that first. Okay, then I find the slope. Slope is 3/5. So I'm going to use the slope of 3/5 to find the next point. Again, slope is rise over run. So this tells me to rise 3 and run 5 from my y-intercept. So I'm going from my y-intercept. I'm rising 3. 1, 2, 3. And I'm going to run 5. 1, 2, 3, 4, 5. And I connect the lines. That's it. That's how we do those types of problems. Let's go ahead and give you 3 problems to try in your own video notebook. Okay, so here are 3 graphs we'd like you to do. Go ahead and try to graph the line y equals 2x minus 5. That's number 1. Number 2, y equals negative 3/4 x plus 1. And number 3, y equals x plus 4. Go ahead and pause your video, and when you're ready to check, push the play button again. Okay, here we go. We got y equals 2x minus 5. Again, first thing we want to do is identify the y-intercept. That's at negative 5. So I mark it on the y. The slope is 2. You could also call it 2 over 1. So I'm going to rise 2, 1, 2, over 1. You could do that again if you wanted to keep going. But you only need to do it with 2 points. And that's what your line should have looked like. Let's work on number 2 here. Y-intercept is at 1. The slope is -3/4. Remember, slope is rise over run. So I rise -3, so that means go down 3. 1, 2, 3, and run 4. 1, 2, 3, 4. When you run, you always run to the right. I've seen a couple students sometimes try to run to the left. You should always run to the right. Y equals x plus 4. X plus 4, that's got a y-intercept of 4, so I mark that. And the slope's a little tricky here. There's no number in front of that x, so it's an implied 1. So we would rise 1 over 1, and that would be the line. Okay, how'd you do? Hopefully you did well. The last type of problem we need to talk about are ones that aren't written in y equals mx plus b form. So, for example, 5x plus 3y equals 9. This problem's not written in y equals mx plus b form. So if we want to use that method, we would have to solve for y first. So that's what I'm going to do. I'm going to go ahead and subtract 5x minus 5x to both sides. So I get 3y equals negative 5x plus 9. I then divide by 3. I get y equals negative 5/3 x plus 9 divided by 3 is 3. So now we have it in y equals mx plus b form. And because it's in y equals mx plus b form, we can go ahead and graph the y-intercept, which is a y-intercept of 3. And the slope is negative 5/3 rise over run equals negative 5 over 3. So this means to drop 5, run 3. So drop 5, 1, 2, 3, 4, 5. You do count the axis. Sometimes people forget to count the axis. I go down 1, 2, 3, 4, 5, and run 3. This would be where my next point is. Whoa, I kind of missed. I still kind of missed. Okay, but you guys get the idea. Okay, so if a line is not in y equals mx plus b form, make sure to solve it for y, and then graph it. Let's have you guys try 3 more. Okay, so here are 3 more problems we'd like you to try to do. You're going to have to get them into y equals mx plus b form first, and then graph them. So, the first problem is 6x minus 2y equals 10. Second problem is negative x plus 3y equals 12. And on this third problem, what we'd like you to do is I've given you a graph of a line. We'd like you to take that graph and use what you know about y-intercept and slope to write the equation in y equals mx plus b form. Okay, go ahead and pause the video, give these a shot, and let's see how you do. Okay, let's go ahead and solve this for y. I'm going to go ahead and minus the 6 over. I get 2y equals negative 6y plus 10. I then have to divide by 2, so I get y equals negative, oh, I'm sorry, this is negative 2y. So I divide by negative 2, I get positive 6, positive 3y minus 5. Oh, that's a little tricky. Make sure to get all your negatives right there. When you do that, I'm going to graph the y-intercept at negative 5. The slope is 3, so I go up 3, 1, 2, 3, and over 1. And this is the equation of that line. On this one here, we're going to solve for y. I get 3y equals x plus 12. I then divide by 3. I get y equals 1/3 x plus 4. So that's got a y-intercept of 4 and a slope of 1/3. So I go up 1 over 3 because the slope is 1/3. And we graph the line. Okay, great. So the last part here was that we needed to write the equation. Now again, when you write an equation, we're going to write out the y equals mx plus b. I'm going to let the b equal the y-intercept, which appears here to be at 1, 2, 3. So I'm going to put a plus 3. The slope, I go from one point to another point is the slope. So I rise 1, 2, and I run 1. So that would be 2 over 1x. You don't have to write it as 2 over 1 because 2 divided by 1 is just 2. Y equals 2x plus 3.